Okay, can we start now? Tell me the order of acidity in the first one. Order of acidity will be what? This is ortho-substituted benzoic acid. Here we have what effect? SIR, steric inhibition of resonance. Okay. This, what effect will have here? Only plus I, meta position. And here we have plus H at ortho position. Right? So, you see, this one is most stable, sorry, most acidic since it is ortho substituted, right? Plus H effect will decrease the acidity more than plus I. So this will be 2 and this will be order of acidity will be this. If you compare here, here we have what effect possible in the first one? SIR, steric inhibition of resonance. What effect we have here? What effect we have here? Tell me. Minus H. Do we have minus H here? See, it is at meta position, Vaishnavi. So we'll have here minus I. Meta position only inductive effect. At para position, we'll have what? Minus H possible. Correct? So this you must know. At meta position, we'll always have I effect. Why? Because when you draw the resonating or hyperconjugative structure, then only ortho and para positions are affected. Correct? So ortho substituted, most acidic is this one. This is first. Minus I, minus H, both will increase the acidity, but minus H dominates over minus I. This will be more acidic than this one. Will have a double bond. Okay. One more question we'll discuss here. COOH, CH3, CH3, and then here we have NO2 and COOH, CN, triple bond N, CH3, CH3. See, in this question, what happens? It is not ortho substituted. So what happens here? Because of this repulsion, NO2 will change its plane. I have discussed one example here. When NO2 will change its plane, so its electron withdrawing nature is not affected over here because it is not in the same plane of this ring. But here the cyanide group is linear, right? Triple bond, it's linear. So here we do not have that much of repulsion. So here minus M is possible here in comparison to this one. And hence, this one is more acidic. Got it? Okay. Okay, so we have discussed so many questions. See, for acidity order, you may have OH also present here. But in case of phenol, when you have OH here, then there is no ortho effect there. Okay. So ortho effect we only apply in case of benzoic acid. Always you remember this. Okay. If you have OH present here, then only we'll see what? We'll see various electronic effects present at different position. According to that, we'll decide. Correct? So you always remember one thing. Ortho effect is only applicable in case of benzoic acid. Okay. Phenol also you can do the same way. Write down the effects possible, whether it will destabilize or stabilize the conjugate base. According to that, you can say. One order I am giving you. This order sometimes helps you to write down the acidic nature. Okay. Sulfonic acid is maximum acidic. S double bond O OH. This acidic order you write down and try to memorize this. Keep in mind. Then we have carboxylic acid. After this, we have phenol. Then we have water, alcohol, alcohol. Then we have alkyne, NH3, RCH, double bond CH2, alkene. And then we have alkane. This order write it down. No, we always take this in carboxylic acid, benzoic acid. Always in benzoic acid. Okay. Now, like for one last thing we'll discuss here, and then we'll see those questions. Okay, 5 more minutes we'll discuss here, and then we'll see the question, the assignment that I have given you. Okay, you see for amines basicity order, if you compare for aniline, in case of benzoic acid we use SIR, but here we have SIP, and that this stands for steric inhibition of protonation. Of protonation. Now, what is it? You see, when you have ortho substituted aniline, suppose we have CH3 and NH2. Ortho substituted aniline, when you put this into water, this forms this product. We have NH3 plus CH3 plus OH minus. Okay. Now, because of this NH3 plus here, 3 hydrogen here, right? And here we have lone pair. Here we have 3 hydrogen instead of 1 lone pair. So again, here we have the steric repulsion. Okay. And to minimize this steric hindrance, okay, the reaction has more tendency to go into backward direction. Okay. To minimize the steric repulsion, the reaction has more tendency to go into the backward direction. Right. When it goes to the backward direction, the basicity decreases. Right. Basicity decreases. Why? Because NH2 has lone pair. When it loses its lone pair, that is nothing but the basic nature. Since this steric hindrance is there, because of this hindrance, it has more tendency to go into backward direction, and hence the basicity decreases, right? So what we can say, ortho substituted aniline is less basic than para or meta substituted. Got it? Ortho substituted benzoic acid is more acidic, but ortho substituted aniline is less basic. Okay, that is why you see when H plus adds over here, that is nothing but the protonation of this compound. Since this, because of this hindrance, the protonation is hindered, right? And that is why we are calling it as steric inhibition of protonation. Is it clear? Steric inhibition of protonation. Got it? Tell me, guys, quickly. We'll see few problems onto this, and then we'll discuss the assignment question. Okay. Now we'll see some questions. So this too you must remember, right? Orthosubstituted benzoic acid more acidic. Orthosubstituted alanine is less basic. See the first question here. NH2 CCl3. Basicity order, you tell me. Tell me the answer. The first one is meta para ortho. Right. So ortho substituted aniline is least basic. So this will be the third one, right? And this CCl3 here, it shows minus I. This is very important, okay? Minus I. And here it is minus H. So minus H will reduce the basicity, correct? So this will be 1 and this will be 2. So we'll have meta, para, and then ortho, correct? Vaishnavi. The second one you see, again this one is least because here we have SIP. Here also we have SIP. Here we have plus I plus H, right? Because of plus H, the basicity increases. So first, then second, and this one is third. Okay, what about the last one? Again, you see we have hindrance here, right? Because of hindrance, the plane NO2 will change its plane, and for this case, minus M is not possible because NO2 change its plane. So minus M not possible, but here we have minus M possible, hence the basicity of this will be more. Got it? Is it clear? Tell me. Okay, so guys, you must keep this in mind, SIP and SIR. Okay, you will definitely have questions onto this in your exam. Okay, so don't forget this. And then what all effects possible according to that will decide. Okay, so we'll stop this session here only. No, not the session actually. Now we'll discuss the assignment question. You have some doubt, right? So I will not be able to see this screen now, this YouTube page. So better what you do, you write down you give me your doubt on the WhatsApp group. I will see the questions there only. Is it fine? Send me your question numbers on that group. I will discuss that here on this screen. Okay. Okay. So text me on WhatsApp whatever doubt you have. Okay. So Vaishnavi has this doubt. Question number 22. All of you can see. The question is this. I will write down the question also. This is A. Next question is this. B. And the last one is this. C. Okay. We have to find out the decreasing order of acidity. Okay. Now you see acidity means what? If this hydrogen, one of the hydrogen from here it will lose. So we'll have a lone pair or negative charge here. If it loses the hydrogen from here, so we'll get a negative charge here, right? And here we'll get the negative charge. Okay. Any of this carbon. You see, this ring is now the C, it is aromatic because we have 6 pi electrons, right? It is aromatic. This one is what? This is resonance stabilized, and there is no effect over here. So stability is what? Stability of C is maximum, then B, and then A. This is the order of acidity also. Third, second, and then one. Option D is correct here. Got it, Vaishnavi? Got it, Vaishnavi? Ritvik and Kushal. You see the next question number 25. Which of the following has most acidic hydrogen? There are two benzene ring attached. Question number 25. You see that? Have you finished it? This question have you done? Vaishnavi, you understood this question number 22? Okay, fine. Okay, Ritik, I'll come to this question now. First, let me discuss this question. Okay, question number 25. You see, Vaishnavi, in this question, what happens? Option C, you see. Option C, right? Yeah, I understood. Option C, you see, the hydrogen over there, you see this, there's a phenyl group present, phenyl, and here we have, hydrogen and PCH3, positive charge. You see, this P has vacant d orbital, right? Vacant d. And when this hydrogen comes out, so we'll get a lone pair over here, right? So this lone pair is in resonance with this vacant d orbital. And that is why this conjugate base is most stable. When you see option D, where we have nitrogen present here, in nitrogen we do not have vacant d orbital, right? And that is why option C is the right answer here. I hope you understood this. Option C is the right answer. Okay. Any other doubt, Vaishnavi? Ritvik, have you finished your assignment? If a compound A is more stable than B, can we say that A is more basic than B? No, we cannot say that. Stability has nothing to do with this basicity or acidity order. It depends on, see, basicity means what? When you loses, okay, Vaishnavi. See, basicity means what? When you loses lone pair of electron, then you get conjugate acid. If that conjugate acid is stable, then we can say the compound with which this conjugate acid has formed is more basic. Correct? Acidity, if you have to compare, remove H plus ion. The conjugate base that you get, if that is stable, then we can say the molecule or the compound from which this conjugate base is formed, that compound is acidic. That's the point. Understood? Ritvik, any other doubt? Yeah, when acidity you have to compare, you remove H plus and then you compare the stability of conjugate base. More stable conjugate base, more will be the acidity. That's the thing. Any other doubt? Next class we'll take some more problems. Okay, GOC there are few things left in this, but we don't see theory much. Okay, we'll take the problem solving session. Okay, we'll solve only problems. P block you want? Okay, then we'll do a little bit, not because 3 hours we cannot do P blocks complete theory, but some important thing I'll discuss in P block. Okay, and then we'll solve some questions also. Is it fine? Yeah. Okay, so we'll wind up the class here only. I will send you one more assignment on these questions, GOC now. Okay, you solve those questions. Okay, because in this chapter you have to do more and more practice. That only make you perfect in this chapter. Understood? Okay, fine. So I am just like we'll wind up the class here only, and I'm sending you the assignment. Okay. Okay. Thank you. Thank you for joining.